Hi, this is David from Electric Teaching, and we're continuing on with making your personal grapher with the integration aspect built into it. So you can see right now I've integrated between two graphs, an absolute value one and a cosine graph that gets a multiplier of x on it. And I've integrated between -1 and 2, but we don't know what the area actually is. So that's the last part we want to do with this project or this video sequence. So I'm going to close this. I'm going to say do not exit altogether so that I can stay in here. Don't worry about the traceback calls in the shell. And now I'm going to come down and add in area information. We're going to have to come all the way down to where I have integration function. So here's my integration function. And inside of here, I'm going to put in first, as we're setting up variables, three different variables. I'm going to call it I'm going to say it's I area 1L. This will be our left end approximation. If you know calculus, that means we're going to get an approximation making rectangles based on the left end height of the rectangle. And similar, I'm going to set that equal to I area right. And same idea, just rectangles based on the right. And then I area t, and we're going to make them all 0. So this is a nifty way in most programming languages you can assign 0 to many different variables at the same time. So that's what I'm doing here. Every one of these three, or all three of these variables, will be 0. The next thing I need to do is I need to make the area for where we can display, so we can display the area information. That's so I'm going to look for, sorry for the play with words there, that was an accident, but I'm going to look for the space on the screen, or the area on the screen where I can display the area information. Actually, it's way back up here. So what I want to do is I want to say below the min x and max x information, that's where I want to display the area information. So I'm going to copy, actually what I'm going to do is I'm just going to copy one of these blits right here. So the variable that holds the blit, and then the blit command itself. So I'm going to copy that. That'll be the easiest way. Paste it in. And now I'm going to take the variable name here, and we're going to call this just I area L. And I don't want to make confusion between variables here. That was not a very good idea there. So I'm just going to say this is just I area plane. And I'm going to use the same I area idea each time. So I area. Okay, and right here I'm going to put the same word. Now the text that I'm displaying, will be left end area is approx. Technically it's approximately, but I'm going to run out of room to put all this text. So I'm going to just say left end area equals. But if you understand calculus, you know that we're approximating the area. It's the exact area of all the rectangles, but it's the approximate area under the curve. And what I'm hoping to do is have both the left end area, the right end area, and the trap area all together here, all next to each other. So this will be I area L. And then I need to move this. This is, let's see, I'm going to go width plus 20. In fact, width plus 20, so that we're right underneath this min x line. And then 150 is the y coordinate coming down. Let's make that 170. 170. Be aware that we are starting to get crowded, so if you make your width and height of your whole entire application here or program here too small, if you make the width and height too small, it may start to lose some of this text being overlapped by other text. So just be aware of that I'm kind of dependent on the fact that I at least have got 400 in the vertical. Sorry about that pause there. Had a student come in and ask some questions. Let me get back to this. Let's see, we got our left end area is equal to our I area L. That'll be perfect. And now what I need to do is I need to have this several times over. I'm going to copy and paste, and I'm going to make some slight changes here. This will be the right end one, right end area, and we'll have this equal to I area R, so that it's bringing in the I area R, which is right now 0. I think I'm going to have these two side by side, basically right underneath the min x and max x line. So I'm going to move this one out to 220 plus the width, so basically 220 off the grid. Now the last one I'm going to paste again. Just use the same variable, reusing that same variable is fine because we only use it once. And then we're going to call this one the trap area, and it will be added the string of the variable I area t. And let's move this one down to 190. So it's going to be kind of important that I have the right height on our program up at the top, and I'm talking about the height way up here at the top that we've established. Right now I've got numbers that fit perfectly for the screen, so I can do the video lesson, but those numbers sometimes don't work in all the resizing. You should be aware of that. All right, back down to my integration commands where we're putting in, let's see, the trap area equal, looks good, have it in the right place. Let's run this and just see if all this stuff has been displayed carefully. Oh, I got a little, sorry. Every once in a while when you don't quit Python completely, it needs to quit on its own. That's all that just happened right there. That's part of programming. You have to understand that part of programming is often crashing the system you're in. And at least Python doesn't have to doesn't take too long to reboot and get back up. So let's try this. I'm just going to put in X and I'm going to hit I just to see if we can see the information we have. Yeah, I'm not exactly positive I'm going to have enough room to print an area with decimals here and with decimals over there. So I think I need to move these right on top of each other. So I'm going to change that. If it looks good for yours, you don't have to change that. That's no big deal. So let me try to make those changes right now so that I definitely will have room to see my decimal answers. So I'm going to make them all 20 off the width. And then we'll go 170, 190, and then 210. 210 for the y coordinates coming down so that they're all 20 apart. Okay, hopefully that'll work. Let's get to the part where we do the code. This isn't too hard. I'm going to come down to area, and we're going to run a little subroutine called for left end. But first thing we need to do is we need to find out where we're going to want to call it up. And so that when I draw the area, I think after I draw the area, I want it to calculate the area. So what I'm going to do is I'm going to get myself and put a little comment here. This is the call out for the functions left end and right end. That's what we're going to do right now. And what I'm going to do is if you make a function and have a variable assigned to this function, whatever value comes back from this function will be in the, whatever number comes back from this function or item comes back from this function will be the variable. So if I go I area L, that's the variable that was set to be 0 originally. And if I say that I area L is equal to a function that I haven't made yet, that I will make, called left end, I will need to send to this function, I will need to send to this function how many graphs we're using, because I might have to do graphs, area between graphs. So I need to know how many graphs, the equation, the second equation, the x-min display will be our starting point, and in calculus that's our a point A, our value A. And so what I'm going to do is I'm going to take the float so that it makes it a number of the x-min display array that we've made above where we are putting in our x minimum value. And then I'm going to say pass a variable called num. Let me, I got to fix something here. I'm going to make a new variable called num here in a minute, and I'm going to explain why I want to do this. And then the last thing I need to do is I need to send it, it's the delta x, the width of every one of our rectangles. And to make this simple, I'm going to always have it based on our k. So every k is our width, or excuse me, or one, if how do I say this? If k is 15, then I want 15 rectangles. So the width of them is 1 over the float, and I got to float the k value so that it works in decimals, and I can actually get numbers with decimal parts to it. If I don't float it, it'll always be rounded to 0 for 1 over k. And that way your area will always be 0, so that won't change it. So I just added this num thing, and I wanted to explain this. In fact, it is something I decided to do that I think If you teach calculus, you might not have liked how I used delta x, or if you know calculus, you might not like how I use delta x here to figure out how many times to loop through and draw the lines, the red lines, to shade in the area. Delta x is technically this information divided by how much, how many k's, or how many times we're breaking it up, dividing it by how many parts we're breaking it up into. So I kind of don't like the fact I use the word delta x here, and I'm going to change this. I don't want to use the word delta x. I'm going to just call it a number. Okay, and this number is how many times I'm drawing lines, or later, how many times I'm making rectangles. So I'm going to change how it's called out here in our range. For I in range, we're going to call that num now, and I'm going to change it here as well. That's the only places I think I have to change it, and I'll find out shortly when I run it. That'll make it so that this is the number of rectangles that we're going to have, or lines, in the red lines that we're using to shade area between curves. So hopefully that makes sense. We're passing that number because I need to know how many rectangles we are making. That's going to be key. This is the width of every rectangle, 1 over float. Okay, sorry about all that teaching. I just want to be sure that you're not just typing this in without understanding. I always try to teach programming so that it is an extra lesson within the math. We have a new function that we need to make, and we are passing to it graphs. I will then just use the same variable. Well, I'll just say graphs. That's perfect. Cool. And then I'm going to just use the same variable, EQ and EQ2. Sometimes I change the variables as they're coming in. For instance, the whole float of the X-min display thing, as that comes in, I'm just going to call that LE for left endpoint. Okay, LE for left endpoint. I'm going to have the number be still an NUM, representing a number of how many times we're going through it. I'm going to keep that M in M. And then since 1 over float k is our true delta x, I'm going to call that dx as it comes in. Double check, I have 1, 2, 3, 4, 5, 6 things coming in. 2, 3, 4, 5, 6, and 6 things being received. Put a colon for the function. Start the left sum at a value. We'll start the left sum at 0.0, 0.0. The space right here isn't important, just something that I like to be consistent in the way I make it. We need to, for every line we drew, just think about that. I'm going to make a rectangle based on that line as the height for doing our approximation of area. So I'm going to say for I in range of num, so doing as many rectangles as we have, colon, our x value to evaluate with our equation will start with the left end point. We start at the left end. But then we increment, add on, by going I times our dx, and our dx is that 1 over k, so maybe 1/15 if our k is 15 right now. Now, I starts at 0, so technically the very first one that's going to be used is LE plus 0. So that's perfect for left end approximation. If, this is key, if graphs equal 2. In other words, if we have two graphs, oh, excuse me, I forgot a line. We'll come back to this in a second here. Go up one more line. We got to calculate the height. So we need the height. The height is equal to the evaluation of the equation based on the x that I just assigned right there. Neat little Python trick. It'll actually calculate the y-coordinate, or the height, and this is just functions that we're working with. So we're plugging in, checking a function there. Okay, if graphs double equal 2, in other words, if we have 2, we need a second height. So we're going to say h2 is equal to the eval of EQ2, the eval of EQ2. Okay, if, now this is key, if when we get the area between curves, we need the height based on the height between the graphs, the height between the graphs. And sometimes in a range from A to B, you're going to have that the heights are one is above the other, then the other graph is above the other. So you got to write a question of if the h value from the first evaluation of the equation is bigger than the h2 value, then we need h to equal the real true height that we're getting will be the h minus h2. Maybe I should use a different word here, like real height or total height or something. But if I am not using this h again after it, then I don't have to worry about that. So I guess we can reassign that h. Just don't get confused between them. Okay, else, this is key, else the other ones, the h2 is bigger, so we need h to be, and I'm just going to write this in a single line right here, h to be h2 minus h, so the opposite effect. That way we always have a positive height. We always have a positive height. Last thing I need to do is just say that the left sum, which is at 0, as it loops through here, needs to keep on adding on new heights, equals, or plus equals, because I'm adding on, the new height, the height I just calculated there, which is the difference between the calculated y coordinates, or the heights of each one, the new height times the dx. That'll just keep adding them up. And then when we're done with this loop, we want to say return the L sum. When L sum gets returned back in this function, I area L will be that value. Let's see if this works. Check. Run it. Oops. Is it running? Oh, I don't know if I hit run. Oh, I hit check module. Hit the wrong one. Oh, I went to the wrong one again. Let me try that again. Run module. Okay, and hopefully I don't get an error. Yeah, unfortunately I got an error. Let me just quickly try this by double-clicking on it. And I'm going to go just a simple value x. I'm going to integrate. And I'm going to integrate from 0 to 2 and hit A. And the left end area didn't pop up correctly. So I'm going to have to find out why that didn't work. So I think I found the error, and how I want to show you how I found the error, because the programming trick I think is important when you're trying to find an error. So in this for loop, I printed LSUM to make sure that LSUM was actually working. Let me run the program real quick, and I'll show you what that does, that print statement does. And so I'm going to integrate from 0 to 2 again and hit A, and you can see the area should fill in basically half of a 2 by 2, so it should be about 2. And if you look over on your shell, the shell is actually showing the numbers as it climbs up, and it actually does climb all the way up. You can't see, it's a bit off the screen here, but it does climb up to 1.96. So that was working. I need to reopen this little runtime error. So I want to show you why it didn't get back to the display point. The display of the area is in the integration subroutine or function. The integration function. Here's where I area L is. But one of the problems or the reason it didn't get back there is that I never returned a value to them. So where at the end of area, I need to say, after it's calculated, to return this variable, and hopefully, I think this will work, and we'll find out in a second, that this will then have that number available and work. Let's find out. I'm just going to do a simple one here. So I'm going to do x, integrate 0 to 2, area. Oh, it didn't work, and I think I know why. I'm just going to come back to the code and rerun it. You can actually do that. You can come back to the code and while the program's, the function's still running, or not. Maybe you can't. Sorry about that. Let me close it. Okay, and what I need to do is I need to actually, where I call up the area command, I need to make sure that it's got a variable equal to that call out. So wait 1 second. Okay, I'm back. Had to unfreeze something there. Sorry about a slight pause there. So where I call out the area command, it's simply, I can run it as well as, where's the call out for the area? So where is that? Oh, sorry, trying to find it. I hit A, so it's right here. So right here, I need to emphasize that I area L is coming back from the return of running that function. So now I've got it that it will run the function, do the graphing, and return. When it hits return, it assigns the left end area approximation. So let's give it a shot again. Hopefully this one works. Again, I don't mind sharing my errors. I'm just running this from 0 to 2, and sure enough, the left end area did put it in. And the print statement is still there too. You can see the print statement back on the shell, so I'm going to delete the print statement, and I'll need to test it on other ends as well. Okay, I only have one more video part for this. I hope you're enjoying this. I'm David from Electric Teaching. Thank you for listening.